Here we're going to be integrating 2x times x squared plus 7 raised to the 10th. So this is a really good substitution problem that we're going to do. So I'm going to use substitution, and with substitution, you want to find that u term. And that u term, when you have u equal to something, what you want to have happen is you want to take the derivative of u, and the goal, hopefully, is that the derivative of u will end up being something that can be substituted out. So for example here, I want to try to maybe do a little bit of this mentally rather than starting to write everything down and then oh, that didn't work, try it again. So I want to look at this problem and say u equal to what, and taking the derivative of that would give me something that could substitute out the rest, because we want everything to be removed in terms of u. So we want all the x's to be out of the picture in terms of u. So if I set u equal to x squared plus 7, I take the derivative of x squared plus 7, derivative of x squared is 2x. Boom. There it is. That means I'm going to be able to substitute that out, and that's going to make life a lot easier. Plus, when you put in u equal to something, you want that term to be something that you could actually integrate. So u to some power, or u being able to integrate that. So if I set u equal to this, u to the 10th, I could integrate that. That's another part that you want to keep your eye on when you're trying to set your u. So u equals x squared plus 7 du, the derivative of u, is going to be 2x dx. And then you want to look to see, okay, I have x dx, nice. If this was x squared or something like that, or x to the third, just something that's not just this x dx, then you got to maybe rethink something and maybe even use a different technique. It's really case by case basis, but here we're fine. X to the first dx, x to the first dx, and bonus, this is a 2, this is a 2, so it completely substitutes out. If this was a 3x and this was a 2x, then we'd have 3 halves out in front because of this 3 and this 2 to try to offset everything, but super lucky there that we don't have to worry about that. The 2 is going to completely substitute out, so I'm going to go ahead and rewrite this as the integral of just u to the 10th, because I replaced x squared plus 7 with u. I substituted out 2x dx with du. So the integral of that is going to be u to the 11th over 11. 10 plus 1 is 11 over 10 plus 1 is 11. Plus c. I guess we could tack that on. And then you want to make sure you substitute back in your u. So u is x squared plus 7 over, raised to the 11th, over 11, plus that constant. And since we're looking at indefinite integral, we have to have that plus c there. So very important. And here's our answer. So this one is interesting because usually that constant won't work out super nice. And that's pretty nice when it does, though. Not complaining.